Welcome to our comprehensive tutorial on building a scalable IoT platform. In this video, we'll guide you through the entire process of creating a robust IoT platform that can handle a multitude of devices efficiently. Let's dive in. Before we start coding, let's take a moment to understand the core components of an IoT platform. An effective IoT architecture typically consists of four main components: devices, connectivity, data processing, and user interface. First, we'll set up our development environment. Make sure you have Java JDK 11 or higher installed, along with Apache Maven for dependency management. If you haven't done so already, you can download them from the official websites. With the environment ready, let's create a new Maven project. Open your terminal and execute the following command. This command initializes a new Maven project for us. Let's move into the project directory. Now, let's modify the pom.xml file to include the necessary dependencies for working with IoT. We will add libraries for HTTP server functionality and JSON handling. Now that we've set our dependencies, let's create a simple HTTP server. We'll create a new Java class named IoT server. This server will handle incoming requests from IoT devices. Let's run our server using Maven. In the terminal, enter the following command. You should see a message that the server has started. Now that we have our HTTP server up, let's define an endpoint for receiving data from IoT devices. We will create a new servlet class named Device Data Servlet. Don't forget to register the servlet in our IoT server class. We will modify the main method to include the servlet. Let's define the device data class, which will represent the structure of the data we expect to receive from devices. Now that our server can accept data, let's send some test data from an IoT device simulation. We'll use Postman or curl to simulate a device sending data to our platform. If you're using curl, here's a sample command. If everything is set up correctly, you will see a message indicating that the data was received. Now we need to ensure our platform can scale. For scalability, we'll focus on a few key strategies: message queues, microservices architecture, and cloud integration. Let's implement a message queue using RabbitMQ, a popular choice for IoT applications. First, we'll need to add RabbitMQ dependencies to our pom.xml file. Next, we'll modify our device data servlet to publish incoming data to the RabbitMQ queue instead of printing it directly. First, we need to establish a connection to the queue. With this change in place, every time data is received from a device, it will be sent to the RabbitMQ queue for further processing. Next, let's create a background service that consumes messages from this queue and processes them. We'll create a new class named Device Data Consumer. Run the Device Data Consumer class in a separate terminal. This service will now be listening for any incoming messages in the queue. When a device sends data, it will automatically retrieve it from the queue and process it. Now that we have the basic architecture in place, let's discuss how we can deploy our IoT application to the cloud for better scalability. Popular choices for hosting include AWS, Google Cloud, or Azure. For this tutorial, let's explore deploying on AWS. Create an EC2 instance and install Java and RabbitMQ so that we can run our server from there. Once your instance is up and running, transfer your project files there using SCP or any file transfer utility of your choice. After transferring your files, navigate to the directory and run the Maven commands to start your IoT server and consumer on the cloud instance, just like you did locally. If everything goes well, your IoT platform will now be live and accessible from anywhere. To make your IoT platform truly scalable, consider implementing a microservices architecture. Instead of having a single application handling everything, break it down into smaller services responsible for specific functionality. For example, a dedicated service for device management, another for handling data, and a third for user notifications. Services can communicate over a message broker like RabbitMQ or use REST APIs. By adopting this architecture, you can easily scale individual components based on load, making your platform responsive and efficient. As we near the end of this tutorial, let's summarize what we've covered. We've set up a basic IoT platform with an HTTP server, handled incoming data, and implemented message queuing for efficient data processing. We also discussed cloud deployment and microservices architecture for scalability. Thank you for joining me in this comprehensive guide to building a scalable IoT platform. If you found the tutorial helpful, don't forget to like, subscribe, and hit the notification bell for future videos. Happy coding!